In this video, we will discuss about three main things. The first one would be angle between two planes. So let's say we have to find the angle between two planes in space. Let's say name as plane pi 1 and pi 2. So based on a diagram here, whenever we want to find the angle, we have to refer to our normal vector. Okay, so our formula is fixed. It's still using the same formula in order to find angle between two vector, which is cos theta equal to n1 dot n2 divided by its magnitude. Here, n1 and n2 are the normal vector for each plane. So let's do an example regarding this. Okay, so given two planes, pi 1 and pi 2 are defined in a Cartesian form here. We have to calculate the angle between these two. So remember the formula just now, we have to use the normal vector for each plane. So focus on plane pi 1 first, that is in the form of Cartesian equation of a plane. And our formula is r dot n equal to a dot n. Okay, so for a dot n part, we cannot do anything, but for r dot n part, we can compare it with our equation. As we all know, r is basically x, y, and z. Means now the coefficient for x, y, and z would be the normal vector for plane pi 1. So from there, we know that normal for pi 1 should be 3, 1, and negative 4. Okay? And then let's do the same for the second plane, pi 2. The coefficient for variable x, y, and z will be normal vector for plane pi 2. Alright, so here our normal vector for the second plane will be 4, negative 3, and 1. Once we obtain the normal vector, straight away we may find the angle. So using the formula, remember our cos theta would be the dot product between those two vectors. So I perform here 3, 1, negative 4 dot with 4, negative 3, 1 and then divided by its magnitude. So we have 9 plus 1 plus 16. And then for the second vector, magnitude would be set of 16 plus 9 plus 1. And then straight away compute this using your calculator. Our theta in this case should be 78.91. So that's all for finding angle between two planes. Moving on to the second thing, in order to find the angle between line and plane. So our formula is still focused using the same formula, dot product between two vectors divided by its magnitude. But here, I will use a different notation. I use alpha instead of theta. So after performing the dot product divided by its magnitude, if our alpha is less than 90 degree, means in order to find the theta, angle between line and plane would be 90 degree minus alpha. And in case our alpha is an obtuse angle more than 90 degree, in order to find the angle theta, we must perform alpha minus with 90 degree. Okay, why this thing happen? So remember, V in this case is direction vector of our line and N is normal vector of our plane. Let's illustrate this situation. Let's say I have a plane here. So normal vector always perpendicular to the plane, 90 degree to the plane. And let's say I have a line, straight line here that passes through the plane. Okay, I name as L. So if we use the dot product between the direction vector of the line with the normal vector of the plane, we will obtain alpha, in this case is here, between the line and normal vector. But our main outcome is we want to find the angle between line and plane. So basically, here, below line and between the line and the plane. So that's the location for our alpha. So we know because normal vector is 90 degree, so this would be right angle. So in order to find alpha, that's why we have to perform 90 minus with alpha. That's how we find theta. If our alpha is more than 90 degree, means it's below of the plane. the other side of it. That's why we have to perform alpha minus 90 degree. That's how you will obtain theta, the same angle here. Alright, so just remember, you must choose the correct vector. For the line, you must choose the direction vector. And then for the plane, we must use the normal vector. So let's do an example about this. Okay, so now our situation is given the plane pi 1 that is in the form of vector equation. So r dot n, clearly from here, you will know the normal vector of the plane. I highlight it with yellow color now. So I just rewrite it back. Our normal plane, normal to the plane would be 13, negative 3, 11. And the straight line L. So that is straight line. Remember the formula of straight line, R equal to A plus TV. Here they use the scala of lambda. It won't affect our equation. Means our direction vector, or V in this case, is vector at the back. So our V for L in this case, or L is line 2, negative 1, 1. Once we obtain these two, straight away substitute into the formula cos alpha. Remember, in order to avoid careless mistake or any confusion, just make sure you use different notation. Not necessarily alpha. If you want to use beta or gamma or any other constant, it's okay. Alright, so I perform the dot product between these two. We have 13, negative 3, 11 dot with 2, negative 1, 1 divided by its magnitude. So for the first one would be surd of 169 plus 9 plus 121. And then for the second one would be surd of 4 plus 1 plus 1. Simplify this up using your calculator. Alpha should be 19.2. Okay. So remember, that is the alpha part. We want to find theta, angle between line and plane. So since this is less than 90 degree, it's acute. So in order to find theta, just do 90 degree minus with our alpha. And in this case, our angle will be 70.8. Okay. So that's how we find angle between line and plane. Alright. So, proceed to the last part of chapter 5 is in order to find the coordinate or point of intersection between line and plane. For this type of situation, we have a fixed step in order to solve it. Okay, so let's go through it one by one. So, step number 1, make sure you prepare your line equation in parametric form. So our line in parametric form. Here in the question, given that the line is actually in a vector equation form, so transform it into parametric. Remember, for parametric, we have three main element or three main equation, which are x. Just choose coefficient for y. So that's how we get 1 plus 2 lambda. And then for y, coefficient for j, so negative 1 plus 3 lambda. And last one for z, we have 2 minus lambda, coefficient for k. Alright, settle with the first step. Moving on, second step, step number 2. So for plane, we must prepare or use Cartesian equation of a plane. So I write here Cartesian equation. So in the question, given that plane is in the form of vector equation of plane, so transform this into Cartesian equation, we should get 3x minus y plus 2z equal to 11. Okay, settle with those two. Now, moving on to step number 3, we want to find the scalar. So, find the scalar. In this question, our scalar is lambda. How do we do this? By substitute line into plane. So, I write it here, substitute line into plane equation. Okay, one by one, start with x. So, we have 3 times with 1 plus 2 lambda. And then minus with y, so negative 1 plus 3 lambda. And then last one plus with 2z, so 2 times with 2 minus lambda equal to 11. After that, simplify that equation so that you may find value for lambda. So I just expand everything now. So we have 3 plus 6 lambda plus 1 minus 3 lambda plus 4 minus 2 lambda equal to 11. So finally, lambda should be 3. Okay, that is for step number 3. Moving on to the last step, step number 4. Once we obtain value for our scalar, okay, I'm moving on now. Step number 4, we will substitute back scalar into our line equation. Why we do this? Because line basically have three main equations just now, x, y, and z, and that would be our coordinate of point of intersection. So for the first one, we have x is 1 plus 2 lambda, so we have 1 plus 2 times 3, that would be 7. Y equation, second one, we have negative 1 plus 3 times 3, and that would be 8. And last one for Z, we have 2 minus 3, that would be negative 1. So from here, we may make a conclusion that point of intersection is basically in the form of coordinate. Remember, 7, 8, and negative 1. And that's how we find point of intersection between line and plane. Alright, so here are the full step. So I just summarize it back. Remember, in order to find point of intersection, step number 1, we must prepare line in the form of parametric equation. And then step number 2, we must prepare plane in a Cartesian equation. After that, just straight away substitute line into plane in order to find the scalar. Once we solve that, substitute back the scalar into line equation so that we may find value for x, y, and z. Automatically, that will be point of intersection between line and plane. Okay, so let's do the last example, another example about finding the intersection point between line and plane. Okay, so now our plane is in the form of Cartesian, and then line in the form also Cartesian equation but for line. So remember just now, step number 1, we must perform or transform line in the form of parametric equation. So this is Cartesian equation. Remember, for Cartesian equation, they basically rearrange that to make the scalar as the main subject. So I just rewrite it back. X now would be 2 plus 3t. I use scalar t. You may use any other scalar, doesn't matter. Okay, second one, y, we should have negative 1 plus 2t. And then last one, z should be 3 minus 2t. Okay, settle with this first step. Moving on, step number 2, we must prepare our plane in a form of Cartesian, and that is basically given in the question. You just have to copy it back, settle with that part. Moving on to step number 3, in order to find scalar, substitute our line into plane. So now we will have 2 times with 2 plus 3t minus with 4 times with negative 1 plus 2t plus with 3 times with 3 minus 2t. And that would be equal to 1. So simplify this up. Finally, t should be 2. Okay, settle with step number 3. Now, moving on to the last step, step number 4. Substitute back this scalar into our line equation to obtain x, y, and z. So first one, x will be 2 plus 3 times 2. That should be 8. Second one, for y, we have negative 1 plus 2 times 2. That should be 3. And then last one, for z, we have 3 minus 2 times 2. And that should be negative 1. So we may make a conclusion here that point of intersection is basically in the form of coordinate. Remember, 8, 3, negative 1. Okay, so that's all for topic 5.